Section 6.6, Trapezoids and Kites, and this is going to be the last section of Chapter 6. So all the way from angles of polygons up to this will be on your Chapter 6 part of your final. Now, what's important to know about trapezoids is that the fact that the definition of a trapezoid is the same, where a trapezoid is or quadrilateral is a trapezoid if it has exactly one pair of opposite sides. Okay, so if it has two pairs of opposite sides, it would be considered a parallelogram. One pair of opposite sides, a trapezoid. No parallel sides would be considered a kite. So these three theorems talk about, well, hey, if we've discovered that it's a trapezoid, what would make it isosceles? Or an isosceles, same thing as like with an isosceles triangle, is it has two pairs of congruent sides, and those sides are called legs. Okay, and then the angles that are opposite of those legs are going to be your bases. So again, so it says if a trapezoid is isosceles and each pair of base angles is congruent. Okay, works the same exact way with your isosceles triangle. You know, same legs are congruent, base angles are congruent. Okay, same thing with 6.22, where we were talking about the base angles, then you know that the sides are going to be congruent. And then, and the third theorem that is that maybe newer, okay, is that it's an isosceles trapezoid if and only if the diagonals are congruent. Now remember, okay, you have a property about rectangles where if it's a parallelogram and the diagonals are congruent, then it's a rectangle. But if it's a trapezoid and the diagonals are congruent, then it's going to be an isosceles trapezoid. So that's why that theorem before in section 6.4, I believe, about rectangles, it's important to prove that's a parallelogram first. So you can prove that, so you can talk about the diagonals, because you don't know if it's a rectangle, or you wouldn't know if that quadrilateral is an isosceles trapezoid just by looking at the congruent diagonals. So this problem says that each side of the basket shown is an isosceles trapezoid. If the measure of JML is 130 degrees, okay, so we've got that JML is 130 degrees, so this entire thing is 130 degrees. And KN is 6.7 feet, and LN is 3.6 feet. Find the measure of MJK, so this entire angle right here. Now, notice, okay, I'm not even going to use the properties of a trapezoid other than the fact of the definition of it. So we know, okay, that JK is parallel to ML because it's a trapezoid. And we know that that pair of opposite sides are parallel to each other. Now, what that does is that can make that JM a transversal. All right, so if we have, hopefully remember back in previous section, if you have a transversal crossing a parallel lines, and the consecutive angles are going to be supplementary. And notice that the measure of angle MJK plus the measure of angle JML is going to be 180 degrees because those are consecutive interior angles. Now we know that JML is 130. So it's using substitution, so that means the measure of MJK is going to be 50 degrees. This next problem says each side of the basket shown, so we've got the same thing. JML is 130, KN is 6.7, and JL is 10.3. And we're trying to find MN, so this right here. Now, since it's an isosceles trapezoid, we know that the diagonals are congruent. So that means that JL, that JL is going to be equal to MK. Those are your two diagonals. Go ahead and put that. So then We know that they're equal to each other, but we know that JL is 10.3 and that MK is the same thing as MN plus KN using that segment addition postulate. And then so 10.3 is equal to, we're trying to find MN. We know that KN is 6.7. Subtract and we get that MN is 3.6 feet. Now we've got quadrilateral ABCD, and it has the vertices that A is 5 and 1, B is -3, -1, C is -2, 3, and D is 2, 4. We're trying to show that ABCD is a trapezoid and determine whether it is an isosceles trapezoid. So again, we're trying to prove that's a trapezoid, so we need to prove that one of their opposite sides are parallel and the other is not. Okay, so we still have to do both. So to determine if they're parallel, we need to do the slope formula. So we're going to do CD is going to be 4 minus 3, 2 minus -2, 1 over 4. All right, and then AB, the opposite side, is going to be 1 minus 1, -1, and 5 minus -3. So we're going to be left with 2 over 8, which is 1/4. So we do have a pair of parallel sides. But now we need to check to see. And even though it looks like it, we got to prove it. So CB is going to be 3 minus -1, -2 minus -3. And we get 4 for 1. All right. And then, let's see, 80 is going to be 4 minus 1, 2 minus 5, 3 over, it's like -3, so -1. So notice that these are not parallel, but these are, so this is going to be a trapezoid. All right, but now we need to prove that it's an isosceles trapezoid, which means that the two legs, aka CB and AD, are congruent to each other. So that's what we're going to prove right now on the next slide. And in the previous problem, we had that A was 5, 1, B -3, -1, C -2, 3, and D was 2, 4. And we had just proven that it was a trapezoid. But our second goal is to prove that it's an isosceles trapezoid. And from the beginning of the chapter, there are technically 4 ways that you could prove that it's an isosceles trapezoid. One, using the definition that the two legs are congruent. And the second one being that the diagonals are congruent. And the other two deal with the base angles, but because we have nothing to do with angles, we can't figure out angles, those two properties are not really useful to us for that reason. So what I'm going to do is I'm going to prove that the legs are congruent just because whenever I think about proving it's an isosceles, I go straight to that definition. So from the previous problem, we had that the legs are AD and we had the legs CB. And to prove that they're congruent, we need to use distance formula. So we have the square root of, 2 minus 5 squared plus 4 minus 1 squared. That's -3 squared plus 3 squared. And that's going to be square root of 9 plus 9, square root of 18. All right, now CB, we've got -2 minus -3 squared plus 3 minus -1 squared. And so that's square root of So negative 2 plus 3 is 1 squared plus 3 plus 4 is going to be 4 squared. And now we've got 1 plus 16 square root of 17. Therefore, because the legs are not congruent to each other, it is not going to be an isosceles trapezoid. Theorem, and we are on theorem 6.24. So we have about 24 properties/theorems that you know, and a lot of them are related, but still, that's a pretty high number. Hopefully you're kind of keeping track, or at least you're familiar or be able to recognize them on a test. But this 24th section or theorem says that the trapezoid makes that mid-segment theorem. And essentially a mid-segment connects the two midpoints of each of the legs. Okay, so in this case, I found the midpoint of FB, found the midpoint of AC, and then they connected the two. All right, and it says that this mid-segment is going to be parallel to both of the bases. Okay, and then it's also going to equal half of the bases added together. So if you added AF plus CD and divide that by 2, you would get the measurement of that mid-segment, in this case BE. So let's use this. It says that in the figure, MN is a mid-segment of trapezoid FGJK. And we're going to try to find the value of x, and x is a value of one of the bases. So using that mid-segment theorem, we know that MN is going to equal 1/2 of KF, first base, plus the bottom base. And now I'm just going to use some substitution. So MN is 30, 1/2, KF is 20, plus JG was X. Now I'm just going to solve. So 30 equals 10 plus 1/2 X. And 20 is equal to 1/2 X. So X is now going to be equal to, once I multiply both sides by 2, I'm going to get X is equal to 40. And then I'm done. Just using that algebra. Kites. All right, so definition of a kite, and that's in your book on page, let me look for it. A kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides, and consecutive meaning they are right next to each other. Okay, unlike a parallelogram, the opposite sides of a kite are not congruent or parallel. So now on this first theorem, it says that if a quadrilateral is a kite, then its diagonals are perpendicular. Okay. Hopefully diagonals being perpendicular sounds familiar with the rhombus. But remember, in order to say that's a rhombus, you first have to prove that it's a parallelogram. That's why it's important to be able to prove it's a parallelogram before you check that the diagonals are perpendicular. Because if it's not a parallelogram, but the diagonals are perpendicular, then it can be a kite as well. So you got to check that. All right, then the next one that says if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. Exactly one pair, and that pair is between the different length sides. So it's not between the two consecutive sides that are congruent to each other, it's between the two sides that are not congruent to each other. Let's use one of these theorems to help us find the angle. So it says if WXYZ is a kite, then find the measure of XYZ. So using the theorems, we know that angle X is going to be congruent to angle Z because they're in between the two sides that are not congruent to each other. So we know that angle Z is 121 degrees. But we're trying to find angle Y. And now since this is a quadrilateral, right, we can't say that, well, since it's a kite, we can't say it's 73 degrees. All right, but we can use the fact that we know that a quadrilateral is all equal to 360. So 360 is going to equal to 121 plus 73 plus 121. plus the measure of angle x, y, z. Right, and then doing some algebra here. I'll get my calculator out. We've got 121 plus 73 plus 121. And so we get 360 is equal to 315 plus the measure of angle x, y, z. Subtracting 315, we get that 45 is equal to the measure of angle x, y, z. And that would be my answer. Alright, last problem, we have that if M and PQ is a kite, find NP. So since this is a kite, we know that we have 4 right angles. The diagonals are perpendicular to each other. So that means that MN is going to be a hypotenuse, and then it's also congruent to MN. So let's find MN by using, since it's a right triangle, we're going to use the Pythagorean theorem and say that 6 squared plus 8 squared is equal to MN. And so we have 36 plus 64 is equal to MN. So therefore MN, sorry, squared, forgot that, so squared. Square root, we're going to be left with MN is equal to 10. No, that's MN, but we need to find NP, but based on those congruent marks, we know that MN is equal to NP. So we know that NP is also going to be equal to 10. And that's how you would do it. All right, so you should now be going through and doing the rest of the 6.6 guided practice, being ready for next class with all your questions, and ready to practice it a little bit more. Okay?